about what categorical statements assert. In other words, what kind of information is contained in each of these types of statements. Here we have an A-type statement, an E-type statement, an I-type statement, and an O-type statement. Let's begin with the A-type statement. So the structure or form of an A-type statement is all SRP. And here we have a Venn diagram which shows the information that's contained in an A-type statement. Notice that here we have two interlocking circles, okay? And each of these circles represents either the subject term, so this circle represents the subject term, or the predicate term. This circle represents the predicate term, okay? Now, we have what's shaded here, all the things that do not exist according to this statement, or can't possibly exist according to this statement. So if all S are P, then none of the things that are S's but not P's exist. So notice how here we have all the things that are S's, and here we have things that are S's and P's, and here we have all the things that are just P's, okay? So if all S are P, then all the things that are not P's but S's don't exist. So we shade them out. Okay? If this is the case, then the statement all S are P is asserting that all the things that are S's are also P's. And there are no things that are S's that are not P's. Now let's look at the universal statement, E-type statement. Here we have the statement no S or P. Once again, we have two interlocking circles, one circle representing the subject term and the other circle representing the predicate term. And they have the overlap here in the middle. Now this circle is all the things, or this part of the circle are all the things that are only S's. This is the things that are S's and P's, and this is the things that are basically just P's. Now, the statement no S or P is asserting that there are no things that are both S's and P's. So this area here doesn't exist according to the statement no S or P. In this sense, the information that's contained in this statement is that all the things that are S's are only S's and not P's, and all the things that are P's are only P's and not S's. Okay? Here we have a I-type statement. The statement's form is some S or P. Now, I-type statements have existential import, whatever the subject term is, exists, and in this case is a P. So in logic, we represent the existential import that one thing exists with an X. Okay, so anytime you see the word some, you're going to use an X to represent that at least one thing that exists. Now, the statement some S or P is saying that there's at least one thing that exists that's an S and a P. So we have our two interlocking circles here, this circle representing the S subject term and the P circle here representing the P predicate term. And the area here is all the things that are S's and only S's. The area here is all the things that are P's and only P's. And in the overlap, we have all the things that are S's and P's. Okay? Now, because the statement asserts that there's at least one thing that exists that's an S and a P, we put the X, that at least one thing that exists, in the area where the S and the P overlap. This tells us that that one thing that exists is both an S and a P. Okay? Finally, we have an O-type statement here. And the O-type statement, like the I-type statement, is a particular statement and has existential import. So it says that some S are not P. So it says that at least one thing exists, which we're going to represent again with an X. Okay? That is an S, but not a P. So here we have the two interlocking circles again. This circle representing the S subject term, and this circle representing the predicate term. And here in this area, we have all the things that are only S's. And here we have all the things that are only P's. Okay? And in this overlap, we have the things that are S's and P's. Okay? And according to this statement, some S's are not P's, so there's at least one thing that exists that's an S, but not a P. So we're going to put this X in the area that is in the S circle, but not overlapping with the P circle. So the X goes right here, in this area here. Okay? And it shows us that there's at least one thing represented by this X that is an S, but not a P. Okay? Now that we understand what these different categorical statements assert, we can move on to talk about the distribution of terms. Now here we have, again, the A-type statement, all S are P. In this type of statement, we have the term S being distributed. So the subject term will always be distributed in an A-type statement. What that means is that for an A-type statement, it is saying something about all the things that are in the category of the subject term. So all the things that are S's, the A-type statement is saying something about. In this case, the subject term is distributed. But this statement is not saying anything about all the things that are P's. Okay? Notice how in this circle, we have basically information left blank in the P circle. So we don't really know anything about stuff that the predicate term represents. So the predicate term is not distributed in the A-type statement. So we have the subject term being distributed and the predicate term not being distributed in an A-type statement. We can contrast this with the E-type statement here. The E-type statement asserts no SRP, and this is our Venn diagram for the E-type statement. Now, for the E-type statement, both the subject and predicate term are distributed. It's distributed because this statement is saying something about all the things that are both S's and P's. What it's saying is that neither of them belong in the other category. So here we have all the things that are S's and only S's, and here we have all the things that are P's and only P's. Notice that in this diagram, the overlap of S's and P's does not exist. Okay? So this statement is asserting something about all the things that are S's, specifically that they don't overlap with the P. And they're saying something about all the things that are P's, specifically that they don't overlap with things that are S's. So the statement no SRP is asserting something about all the things that are both the subject term and the predicate term. So both the subject and predicate terms are distributed in an E-type statement. Now let's look at the I-type statement. For the I-type statement, it asserts that some S are P. Now remember, we put the X that represents the at least one thing that exists in that I-type statement in the middle where you have both an S and a P. So that X, that at least one thing that exists, is both an S and a P. And we have blank here anything that's just an S and anything that's just a P. Now, according to this statement, it's not saying anything about all the things that are S's and all the things that are P's. Notice how we have blanks over here, nothing shaded, okay? So in this case, this statement actually asserts nothing about all the things that are S's and all the things that are P's, so the subject term and the predicate term are not distributed. Finally, we have the O-type statement. Now, understanding the distribution of O-type statement is a little bit confusing for a lot of people. Now, the O-type statement asserts that some S are not P, okay? So we have an X in the circle, okay, of the S term, but only in the area where it is just an S, okay? and here's the area in the P term, that's just the P, and here we have the overlap SP, okay? Now, this statement actually does assert something about all the things that are P, okay? But it doesn't assert something about all the things that are S's. Notice it only asserts something about just some of the things that are S's, not all the things. So the S term, the subject term, is not distributed, but the predicate term is distributed. Now you might want to ask yourself, why is it that the subject term in this is not distributed, but the predicate term is distributed? The subject term is not distributed because the statement doesn't say something about all the things that are S's, only some of the things that are S's. But the predicate term is distributed. Why? Because it is saying something about all the things that are P's. What is it saying? It's saying that of all the things that are P's, there is at least one thing outside of that category. So it is actually stating something about all the things that are P's. Specifically, there's at least one thing outside of that category that's not a P. In this case, then, we have the predicate term distributed, but the subject term not distributed. Okay, now let's talk about doing some Venn diagrams. Now, Venn diagrams are basically ways of representing the information within categorical statements, okay? So this is a procedure that you'll use in order to do a Venn diagram of categorical statements. Later on, we'll discuss how to do Venn diagrams of categorical arguments. So here, what you want to start with is two interlocking circles where each circle represents the one of the terms in the statement. You want to locate the circle that represents the subject term of the statement, and you want to do all your work in that circle within the subject term. Then, for universal statements, you want to shade what cannot possibly exist according to that statement. And for particular statements, you want to put an X in the area where something exists according to that particular statement. Okay? So, let's do some examples here. Okay? Okay. So here we have the statement. It's an A-type statement. All cats are mammals. Okay? So we want to draw two interlocking circles. And we have S representing our subject term, cats, and we'll do P to represent our predicate term, mammals. And what you want to do is basically, because this is a universal plane, you want to shade everything that does not possibly exist according to the statement. Now, this area here is where you have S's and only S's. Here you have P's and only P's. And in the middle, you have things that are both S's and P's. Now, according to the statement, all cats are mammals, what does not exist is all the things that are cats but not mammals. Okay, so all the things that are S's but not P's. So here we have in the subject circle, okay, in the circle for our subject term, which is where all our work will take place, okay, here you have S's that are not P's. And according to this statement, that doesn't exist. There are no things that are S's that are not P's because all the things that are S's, all the things that are cats, are P's. So you want to shade the area where you have only S's that are not P's. Okay? Okay, next we have the E-type statement, no SRP. So again, we have two interlocking circles, S and P. And I'm going to label the inside areas just so you can see. So here we have the S area, this is SP, and this is P. And this statement, no cats are mammals, it asserts that there are no things that are cats that are mammals. So what doesn't exist according to this statement is anything that is both a cat and a mammal, anything that is both S and P. So we want to go ahead and shade that area here. Now, because these are two universal statements, we use shading to represent what does not exist according to that statement. So here we have the I-type statement, some cats are mammals. And in order to do a Venn diagram of this, we are again going to create two interlocking circles, okay? One representing the subject term and the other representing the predicate term. And I'm going to go ahead and label the areas inside these circles. So this is the area with just S's. This is the area with just P's. And in the middle, we have areas that are S's and P's. Okay? Now, this statement here says that some cats are mammals. So there exists at least one thing that is a cat and a mammal. Because there exists at least one thing that is both an S and a P, we're going to use an X to represent that one thing. And that one thing will go here in the middle where you have things that are S's and P's, cats and mammals. So here we have the Venn diagram, which represents the information contained in that I-type statement, that at least one thing exists that's both an S and a P, or both a cat and a mammal. Okay, let's move now to our final statement type, O-type statement. And our example here is some cats are not mammals. So again, we're going to draw two interlocking circles, and we're going to label them S and P, standing for our subject term cats and our predicate term mammals. And I'm going to go ahead and label the areas inside. So this is where you have only S's, this you have only P's, and here you have S's and P's, okay? And again, this is a particular statement which asserts something about some cats. So it's saying something about at least one thing that is a cat, and that at least one thing is a cat is not a mammal. So you have at least one thing that's an S that is not a P. So you're going to put that X in the area where it's an S but not a P, which is this area here. Okay? So we have our Venn diagram of our O-type statement, which represents the information that there's at least one thing that exists, that's an S, a cat, that is not a mammal, that is outside the entire circle of things that are P's. Okay? Okay. Now, other than understanding distribution of terms and what these categorical statements assert, what you want to know is something about how the statements are, have contradictory claims that they make depending on what type of statement it is. So, what we're talking about here is the modern square of opposition. Opposition refers to when two standard form categorical propositions refer to the same subject and predicate classes but differ in quality, quantity, or both. And the modern square of opposition is a chart that illustrates the relations of contradictory and logically undetermined truth values between these statements. So here we have the modern square of opposition. Notice that in the modern square of opposition, we have the A-type statement here in the corner, the E-type statement here in the right corner, I-type statement here in the bottom left, and the O-type statement here in the bottom right. Now these represent types of statements. So the A-type statement is all structured, all S, R, P. The I-type statement is structured some S, R, P. And the E-type statement is structured no S, R, P. And the O-type statement is structured some S, R, not P. Now these are opposing statements in the sense that they differ in quality, quantity, or both. So here you have quantity all, and this opposes the quantity some. Here you have the quantity no, and it opposes the quantity some. And then you have the quality, which is, this is affirmative, and you have it opposing the negative quality here, and this also is affirmative, and you have it opposing the negative quality here, okay? Now, given that you have these different types of statements, they're related to each other in various ways. So here we have an A-type statement is a contradictory to an O-type statement, meaning that if an A-type statement is true, then its contradictory is going to be false. So the O-type statement will be false. So if it's the case that all cats are mammals, then it will be false that some cats are not mammals. And if you have an E-type statement and that's true, then it will be false, it's contradictory, an I-type statement. So if it's the case that no cats are mammals, then it will be false that some cats are mammals, okay? It also works the other way in the sense that if you have an O-type statement that is true, so it's true that some cats are not mammals, then the A-type statement will be false. It will be false that all cats are mammals. And if it's true that some cats are mammals, then it will be false that no cats are mammals. So these are the relationship of contradictory statements, okay? Now, all the other relations, the A with the I with the O with the E, and the E with the A, are logically underdetermined. What this means is that we can't tell what truth value one of these statements have based on its opposing statement. So if you have, for example, a statement, some cats are mammals, being true, okay? So if it's the case that some cats are mammals is true, okay, then we don't actually know, based on this being true, whether or not some cats are not mammals is also true, okay? You can't tell by logic alone. What you need to do is actually go to the information that's contained in the statement. With these examples, we actually know that it is the case that some cats are mammals is true, and some cats are not mammals is false, okay? However, consider this type of statement, some apples are green, okay? Now, if this were true, we wouldn't necessarily know that some apples are not green is true, okay? We'd have to go to the content or the information that's actually contained in this statement. So in this case, some apples are green is true, and some apples are not green is also true, okay? Because we know that there are apples that are not green, red apples, yellow apples, etc., okay? One really great thing about the modern square of opposition is that it can help us figure out or give reasons for why statements are true or false. So for example, if you have the statement, all cats are fish, okay? And you know that this is a false statement, okay? The reasons to support your claim that this is a false statement can be that its opposing statement, the contradictory statement, is actually true. So we have that it's true that some cats are not not fish. Okay? So in order to prove that all cats are fish is false, we can suggest or show that there's at least one cat that is not a fish is true. Okay? So the contradictory statement is true.